So FinGeoRisk is a cutting-edge spatial intelligence platform designed to transform how we understand environmental and financial situations. By using high-resolution satellite imagery, topographic raster data, and crime risk analytics, our program is able to compute a complex risk profile on the area that the person is interested to buy in. By using an XGBoost model and Google Gemini adaptive AI, we can turn a complex system of understanding localized and sparse risk into a simple and easy UI for a normal homeowner to understand.
Great.
So currently, new property owners and new investors do not really know how to buy a property. Usually on the web, there's sparse and very localized data sets that either contribute to one specific area or lock behind paywalls. And most of the time, these people have to make complex calculations by themselves. Some of these people don't know that type of stuff unless they've taken a degree into it. But with our sorry, but with our data provides a proper way for individuals to identify immediate and compounding site vulnerabilities, such as how high vegetation can contribute to higher wildfire risk, right? And how being close to water can lead to increased risk of flooding, which would increase premium costs and insurance. So we use environmental risks do not exist in isolation. They're usually tied to one another. So for example, high leaf vegetation contribute to wildfire, but at the same time it can contribute to increasing the price of a property because it's more aesthetics, right? But for with our model, the user can understand the complex risk behind that. If adding too much of that vegetation can out exceed the cost of actually using it for aesthetics. Furthermore, commercial real estate investors, usually the site's profitability is tied to them buying it, right? And that's usually tied to how much risk the property has. So using real-time proximity to infrastructure nodes and topographic gradients allows portfolios to proactively hedge against localized climate and buy specific tracts of land that will increase their profitability chance.
Okay.
So our solution to all of this is FinGeoRisk. It uses multiple sources of geospatial data, including satellite imagery rasters, elevation profiles, and tabular safety indexes to create a singular, cohesive computational platform that eliminates information silos, so like those large spatial data sets. Furthermore, we use a complex model called with XGBoost to take all of these complex data sets and values into a simple number that the user can identify whether it's how risky something is. Furthermore, since just a number is not alone to determine if someone wants to buy a house, we use a layer of Gemini to take all those values and simplify into simple and understandable statements that the user can use to understand how risky their settlement is and if they want to take that risk. So I'll demonstrate it for you.
Yeah. So considering from this presentation, this is for house buy and house sell, right?
Yeah.
That how we can make it easy for the person to buy or sell a house depending on the features around that house or where the
How
house is.
risky it is. Yeah. So this is
Great.
our onboarding site. Here, users can get to know what our site is about with some information on what it has.
Okay.
So we can get started now. So depending on who it is, we have either a homeowner panel or investor panel because not all investors will buy one specific piece of land. So I'll show the homeowner first. So right now we're in the interactive for the homeowner panel. And for homeowner, it's mainly just buying a piece of a property, right? So they can enter their property, right? And then they can press search. So now it will be so in the back end, we'll be loading a bunch of data sets. And from those data sets, it's going to go into the model, and the model will come back with a risk score.
Okay.
So it usually takes around 10 or 15 seconds.
Okay. So you have used the map API, right, to exactly grasp the location where you want to buy the house or
Yes.
exact location, right?
Hmm. Well, what I do is I get the location, right? And then from there, I add 5 miles by 5 mile bounding box. So it was going to pass in four coordinates, my bad, of four
Okay,
latitude coordinates for a box. And that's going to go into the data set.
okay. Got it. So you're marking the edges of the house and then showing the data, right?
Yeah. So it's
Okay,
because just the house itself won't have any risk, but the area around it.
right. So the process was something like that, that you have data set. So you trained
Yeah.
a XGBoost model. Now
Hmm.
these points are being shared to the model, right? And then
These
model
points,
predict,
yeah.
yeah,
So these points are going into the datasets APIs, right? And those datasets are going to come back with a huge text file, raw text file. And then we pass that raw text file into Gemini. Gemini is going to
okay,
parse that text file into understandable code, and it's also going to search up crime metrics, like the crime in the
okay,
area. And then all that's going into the model.
great. That is actually a good workflow because the model can't provide the best results which we want, right?
Hmm.
So providing it an API will make it much more good for the person to get, or it
Yeah.
is better for the person to get the idea how the features around that location.
Hmm.
Very nicely.
Yeah, it's almost done. There we go. So right now we can see the risk of 54.6. This is how risky the place is. And AI is going to turn this into, so as I said before, Gemini is going to turn this into something understandable for us. So we can see it's a low crime index of 1.2, but there
Okay,
is a high flood risk we can see right here. So down here is some of the like the very strong pieces of information that heavily affect the XGBoost model. Crime is a
okay,
big thing, slope, vegetation, and flood, and also infrastructure. But three main things are vegetation, slope, and flood. So for each one, I've made a simulation for people to understand. So right now we see 0.25 is a very low score. And
okay,
here it creates like a potential, so it uses the model to create a like the forest around us, right? And then we can select wind direction and wind speed. And I can pick a spot where I would say a spark would occur, and we can run the wildfire diagnostic. So it will create a like real time of how much the fire would spread and see how risky it is for potential fire affecting your home. And then I have slope gradient. This will tell us how much the foundation will settle into the ground, which actually counts a lot because you need to pay for it to get fixed. So right now we can see a slope is 4.2 and it's running. So it says in estimated 23 years, the foundation will shift by 11.4 centimeters. Not that much, so it's pretty nice.
okay,
And then here's flood proximity. So it's saying, so depth is zero point 0.0, saying, so the water hasn't reached anywhere. So if there's potential flooding, there's a chance of 4.6 feet of water to go to you. So that's actually kind of dangerous.
right,
So furthermore, we have a financial and insurance intel. So here we'll take the data and it'll put it into like a model for people to understand how much their price will go up or go down, monthly rent, appreciation value. It'll tell price per square feet, rental yield, area income, employment rate, and investment risk. So it's a 3.5 out of 5. And for more usability, we have like a settings function where people can set their theme, picture color, if they want to change from normal view to satellite view, reduce animations, and change their slope to percents. And then over here, there's an AI panel, so I can say how risky. This will actually go through the AI, and the AI will give us a response based off all the data over here.
okay,
So yeah, see, it says, yes, it tells us it's flood zone A, high risk, and then there's a 54.6% risk. So it takes all the data that comes from the score, and then Gemini gives us a detailed analytical response. So do
great.
you want me to show you the investor side?
Yeah, please. You can say that.
Let me just reopen this. So let's search up an area. So unlike the other one, this one you can actually actively search up places of land. So if we pick, let's pick here, right? I can use this to create a bounding box around the area I'm potentially wanting to buy. Now this will go into the model, and the model will create a risk score based on that area selected. So what it'll do is it'll take these four nodes, it'll calculate the center of the nodes, and then add 5 miles to each.
In this as well, the process same first it goes to XGBoost model, then to Gemini.
Yeah, it's same
So
thing.
just the factors are different for the investor and for the seller, right?
Yeah, it's just selecting the land because investors don't buy one house; they buy lots of stuff. So right now, Gemini is actually searching the risk of the area. This is Memphis, so we're looking at a kind of a higher risk in crime.
Okay,
And then once that's done, it will form it into understandable like code for the XGBoost model, and it'll feed it in, and the XGBoost model should come out in like half a second.
okay, great. So what do you think? The time for this much processing is actually being used by the XGBoost model or the Gemini?
Gemini,
Who is okay?
yeah. The model comes out in like 5 seconds. It's just the AI. But in the future, I might actually try to make a fully usable thing where AI is not used into this, but built into the system, so it comes out really quick.
Okay. So you want to fully diverse to the model basis only. Your custom LLM more
Yeah.
preferred to say.
hmm So yeah, it came out now.
Okay.
So we can see crime risk was 4.3. Memphis is really dangerous for people.
Okay.
And it gives again, this gives us the risk of 62.27, high crime risk, significant security concerns. And
Okay.
same thing as before, everything else is also the same. It gives us all of this stuff.
Got it.
Only thing different is this, and also all the functionality is the same.
Yeah. Got it.